Welcome Year 8s to this video. In it, I'm going to take you through the circumference of a circle. Now, what you've done already is a short activity where you measured the circumference of 3 different circles using string, and you also measured the diameter of some circles as well. And what you would have found is that when you did the circumference divided by the diameter, that you found something in common with your results. So you may not have got exactly the same results, but what you should have found as a class is that every time you did that, the diameter fits within the circumference just over 3 times. So circumference divided by diameter was 3 point something, something, something. So to begin with, we are going to grab out our summary books and we are going to write a heading, circles. And I'd like you to have a nice little diagram. It doesn't have to be a perfect circle. They're hard to draw by hand. But I'd like you to basically label on your circle the circumference, which is the distance all the way around the outside of the circle, the diameter, which goes from one side of the circle, so the furthest side of the circle through the center to the other side of the circle. It's called the diameter. And then this one, which we haven't really, you wouldn't have used in the activity just yet, but we will actually need it when we look at the area of a circle. So if you have a look here, it goes from the center of the circle to the outside. So not like the diameter goes all the way across. Radius just goes halfway across your circle. So if we can have in your summary book, and you can just pause here if you like, a lovely diagram with the labels on it, because these are key vocabulary that you will need for all your work with circles. The other two terms, the first one you'd be familiar with, and that's a semicircle. So you can draw a lovely semicircle and label it. And the other one is called a quadrant. So that's 1/4 of a circle. So imagine like a pizza cut into 4 pieces, and you've just got one of those pieces. We actually call that a quadrant. Once you've got your diagrams, we'll then continue and we'll look at circumference. So just over here, this is basically a summary of what we found from that measuring activity. We know that for any circle, that when you take the circumference and you divide by the diameter, you're going to get this number just over 3. Now, if we were able to measure really, really accurately, so say we were to use a computer program to measure the circle, we would find that this number always comes out exactly the same for whatever circle we look at. And the number itself actually doesn't end, it keeps going, and that's why I've put a dot, dot, dot. So it's 3.14, but then it goes 159265 or something like that. But we tend to just round it off to 3.14 to make things easier, and we call that number pi. So pi, it's got a different spelling to the pie that you eat, and it's got this Greek symbol here. So I would like this as well written into your summary book. So again, just pause at any stage so that you are able to put this summary in there. Now, the reason this is so significant, the reason that finding this fact about circles is so important, is that because we don't really want to have to measure circles the way that we have in that activity that you've done in class today. You would have seen that measuring a circle with a piece of string, the circumference that is very difficult. And you'll see as well that you would have got a slightly different result to another group because it's, fraught with inaccuracy. So what we want to be able to do is we want to have a mathematical way to find the circumference precisely, exactly, no matter what circle we're looking at. And that's where this will come into play. Knowing that the diameter fits into the circumference pi number of times, so just over 3 times, we can then use pi to find the circumference of any circle. And you'll see here I've actually got a formula for the circumference. This comes from that fact about the diameter and the circumference. So what we can do is if we want the circumference of a circle, we can take pi, which is how many times the diameter fits in the circumference, and multiply it by our diameter. So say we had a diameter of 1, that means our circumference will be 1 times pi, so it would be a 3.14. Now you'll see I've written it in words here, but generally you're going to be writing it like this. because we are going to be writing our formula every time we approach a problem, so that we are demonstrating what recipe or what we're using to get the circumference. I'll show you a couple of examples, and then I will show you as well a semicircle and a quadrant. So they were the two special types or parts of circles that I showed you before. You will need your calculator for this, so make sure you've got that. And here's a couple of examples to start us off. So first of all, if I'm finding the circumference, I would write C equals and then pi times d, like so. Now, I'll obviously do that for this one as well, but that one there I'll get to in a moment because that one's got a special thing we need to do first. So what you'll notice is I've got a diameter of 10. So my next line is going to say pi times 10. So just like we've talked about in class, we write our formula first, and then we write our substituted values that we know in here. I know that D is the diameter because it's measured all the way across the circle, as this one has been. Now, if you type that into your calculator, it's likely the calculator will tell you that the answer is 10 pi. Now, that's not wrong, that's correct, but that's what we call an exact answer. It's exactly 10 pi. Because what we know about pi is we get, it's called an irrational number. We get lots of decimals after that decimal point, lots of decimal places. So this is called exact, or it's called in terms of pi. In terms of pi, all right. Now, that will happen with other ones in your calculator, but I'll show you how to get what we call an approximate answer. So we can see roughly what is the circumference. So in your calculator, you might have typed this in. So our pi button is just over here. So if you go to 7 and you go up 2 and across 1, you'll find pi. And if I do times by 10, you'll see what I mean. It says 10 pi. So all you have to do is press this little button above the enter button. So it's got two little arrows left and right. And when you press that, you'll notice it changes 10 pi to an approximate answer of 31 point, and I'll just go to one decimal place, 31.4. Oops. And you'll see as well that it's in centimetres, so I need to make sure I put centimetres here. So it's 31.4 centimetres all the way around that circle that's got a 10 centimetre diameter. So that's one example. I wanted to show you a second one. Now remember, just pause so that you can write this in your book as well. I wanted to show you a second one because this one here, the diameter is actually not being given to us. This here, from the middle to the outside, 1.5, is called our radius because it's only halfway across the circle, not the full way across the circle. So if I want the diameter, I just have to think about extending this, which is just adding another radius. So my diameter is actually 2 times 1.5, or 1.5 plus 1.5. And that's going to give me a diameter of 3. Once I've got my diameter, I can do exactly what I did before. I write my formula first. I'm going to do pi times d. And then I'm going to substitute, so just change colours. So my circumference is, I write pi again, because remember we're just going to be pressing that pi button like you saw me do before. We don't need to write 3.14 because the pi in your calculator is already stored. It's already got the number and it's got it to lots of decimal places, so much easier that way. So when we do this, it'll say that the answer is 3 pi. That's an exact answer, but approximately we're going to find it. So I'll just clear that. We do pi times 3, and we see 3 pi, and then we just press our little arrow button. So 9.4 to one decimal place. Okay, and that's in metres this time, since that one there, the radius was given in metres. To finish off, so pause here so you can write that one down. To finish off, I'm going to show you just 2 more examples And that's where we are finding the perimeter. So you notice it doesn't say the circumference this time because we're not talking about a full circle. We're talking about part of a circle. So the name or the word has changed to perimeter. And that's only because we don't just have an arc. We don't just have a curved part of the circle. We actually have these flat bits as well that form the perimeter of the shape. So with the quadrant, we've got a flat bit here and a flat bit here. And we've got this little curved bit. So to solve something like this, we just consider that a semicircle is half of a circle and a quadrant is a quarter of a circle. We're going to use that fact to solve these ones. So first of all, I'm going to deal with this curved bit. This curved bit around here, if I was finding a full circle, I'd be finding the circumference. But I'm not finding the full circle, I'm only finding half of it. So I'm going to call this, this bit the arc. You can say arc length because that's technically what we're finding. So the arc length is going to be whatever the circumference was halved. So the circumference divided by 2. So remember the circumference would have been pi times d. But I don't want the full circumference. I only want half of it. I don't want to go all the way around the circle. I just want to go halfway around the circle. So that part will be pi times d, which is 8, pi times 8. So just check that it goes all the way across. It does. And that's divided by 2. Now, when you put that in your calculator, what you'll see is it will simplify that. Pi times 8, and then we'll divide that by 2, and it will tell me that it's 4 pi. Now, I'm just going to leave it like that for now because I'm actually not finished. 4 pi. The reason I'm not finished is because that was just the arc part. That's the curved part of the shape. I want the full perimeter of the shape. So you'll see I need to add this side length in as well. So I call that the flat bit. Don't forget about the flat bit. So if we've got the full perimeter, I need to take the arc, the curved bit, and I need to add any flat bits. So I've got one flat bit that's got a length of 8. And this is where I'll get my approximate answer. So I've got 4 pi. I'm just going to press plus 8. You'll notice it says answer. So it's saying it's going to take this answer and it's going to add 8 to it. And now I've got my solution. Now I'm going to round to 1 decimal place. So I can't just put 20.5 because I need to check the number after it. The number after it is 5 or above. So that means that this is actually closer to 20.6. And so I'll round it to 20.6. And that is in centimetres. So as you can see, it's a little bit more challenging. You do have to consider halving the circumference first. And you also have to remember that we've got a flat bit here that's part of the perimeter of this shape. Now the quadrant is very similar in that we are going to find this arc part again. So I want the curved bit, the arc length, I'm going to call it. You just say arc if you like. This time though, I don't want half of the circle. I actually only want 1/4 of it. If I keep this going, there's 1 piece, 2 pieces, 3 pieces, and 4 pieces. If I only want 1 out of the 4, so 1/4, remember we said that before, that means that I'm going to have to divide the circumference by 4. So pi times d is my circumference. Divide that by 4. Now you also have to be careful here because if you have a look, this side length, 2.5, that is from the center to the outside of this. If the circle was full, this would be the center of the circle here, and that would be the outside. So this length here is actually the radius. That means that the diameter is 2 times that. 2 times 2.5, which means that it's 5. And so we'll put that in here now, pi times 5, and that's going to be divided by 4. Now when you put that in your calculator, it'll probably come out as 5 pi on 4, I'll show you. It does. So it simplifies it to a fraction. Now don't be afraid of that, 5 pi on 4. We just write it as is, 5 pi on 4, because remember it's keeping it exact. And the last thing we're going to do is we're going to add the flat bits. Now, there's actually 2 flat bits on this one. That one only had one big long flat bit, the 8, but this one's got 2.5 here, and it's also got it across here, because from the center to the outside of the circle is always going to be the same length. That's called the radius. So to finish off, I've got my 5 pi on 4, and I'm going to add my diameter. I'll add 2 times the radius. So you can add, you can write 2 times 2.5, or you can write 2.5 plus 2.5. I'm just going to write plus 5, because that was my diameter from up here. That was this bit. And then we finish it off. So if we go back here, I've already got 5 pi plus 4 there. So I'm just going to put plus 5 and press enter. And now we'll round it off to 1 decimal place. So I've got 8.9. The next number is a 2, which means that this number can stay as a 9. So 8.9. And the unit was meters. Right on time, there's the bell. So I'll stop right there. And now what you can do is you can have a go at the worksheet that I have shared with you. The questions I'd like you to do from the worksheet are on your work plan. Please make sure your workings are done in your book. Please make sure you are writing any formulas you are using first, and you are working down the page. Let's avoid working across. Let's work down the page, and I would like you to replicate the same workings that I have done as much as possible, please.